and welcome to Utkarsh Minds Python for Data Science. In this video we will see how in Python we can write the program for binary versus binary unpaired test and descriptive as well as inferential statistics. First, since we are working with Python, we will open a Colab notebook, colab.research.google.com. Then new notebook. Once the notebook is open, we can give it a name like binary versus binary and connect. I will then upload the data set. The name of the data set is student statistics. Once the data is uploaded, we can write our Python code for reading the data in Colab. So I will create a variable, and in that variable I will read the CSV file. So we have read the file. These are the different columns, and total we will have around 50 different columns in the data set. We are interested in two columns. One is the binary column named secondary school, and another is the binary column named gender. So I will first display the gender column. It has 34 males and 12 females. Next, I will display the secondary school. Here we have Netherlands 24, and there are also other African and Asian locations. What I will do is I will convert this data into binary. I will keep only the Netherlands and others. Anything that is not Netherlands will be converted to others. For that, the column will be secondary school. In this column, I will identify all the data that is non-Netherlands, and so this symbol not equal to the Netherlands. So all this will become others. And only there will be Netherlands and others left in the data. So it will become binary. Okay, so others is 31 and the Netherlands is 24. These are the values present in this column. First step is to get a descriptive statistics from the data. For that, cross tab is a very useful function. we will create a cross tab. So pandas dot cross tab and pass the two different columns. First one is gender and the second is secondary school. I will display this cross tab. First female, then male, and then there is others and Netherlands. With this data we will create a plot. So my cross tab dot plot kind equal to bar. So with that first we will have to define once we have defined, we will create a cross tab from the data. So you can see others and Netherlands, and on this left hand side there is the total count for each category, female and male. Next will be to apply the Fisher exact test. There are two hypotheses. As I said, null hypothesis is saying that there is no influence of gender on secondary school location. And the alternate hypothesis is saying influence of gender on secondary school location. So with this we can import from scipy dot stats import Fisher exact and pass the cross tab as input. Oh, the spelling is wrong. With that we have got a p value of 0.32. Because the p value is not less than 0.05, it is 0.32, we cannot reject the null hypothesis. So we say no evidence to reject the null hypothesis. Usually when p value is not sufficient to reject the null hypothesis, we do not calculate our effect size. However, to demonstrate how we can calculate the effect size, we will assume that p value is less than 0.05, and with that we will calculate our effect size. So effect size is odds ratio. In odds ratio we will use the 4 different values that we have found in the previous cross table. A will be row 0 and column 0, B will be row 0 and column 1, then we have C and D. So these will be row 1 column 0 and finally row 1 column 1. Odds ratio is simply the division of A by C and B by D. Then to interpret this, we have if the odds ratio is between 1 to 1.49. So if odds ratio is less than 1.49, then we can print that it is negligible. If it is less than 3.5, 3.45, then we print that the odds influence is small. If it is less than 9, we print it is medium, and finally we print that it is large. So we have got negligible as the result. Then we take all this and write a report. We will say that Fisher exact test did not find an influence of gender on location of secondary school. Here I will have to say that p value is 0.32, and further the odds ratio effect size was negligible. Here I will quote the effect size value as, how much will it be, 0.44. So this will be our final report. Only I have to mention that because the p value was not less than 0.05, there was no need to calculate the effect size. Still, to demonstrate the formula, I calculated the effect size for you. Thus, in this video, we have seen cross table, clustered bar chart, Fisher exact test, and finally odds ratio. Thank you for watching, and in the next video we will see further hypothesis testing.